Okay, so I'm just guessing on what homework problems might have been difficult for you. I don't really know, so this is a shot in the dark. So if everybody got 61, feel free to skip. I did 61. I'm trying to hopefully do 65, and then I think it was 127 on the other page. So, let me know if I guessed right or not, but feel free to skip. Okay, so now we get this. We're going to do logarithmic differentiation. So notice that no calculus is happening at this time. I'm trying to stress this. This is not calculus, right? What I'm doing right now. Okay. So that's good. Still not doing calculus, just rewriting with pre-calculus rules right now. Okay. Now is the time where we do calculus. So this is all pre-calculus. Hopefully you're okay with it. So what we're going to have is 1 over y by the chain rule. Because the variables don't match, we tag on our dy dx equals. Now this is just that's just 2 to the 2x to the negative 1. So if we think about this as a product here, with this being the first part of the product and this being the second part of the product, we can do this. So derivative of the first is going to be negative 2x to the negative 2 times the second, which is just ln of x, plus derivative of the second, which is 1 over x, times the first, which is 2 over x. So simplifying all of this, we're going to have, I guess I'm just going to put dy dx, and I'll multiply by a y right now. Everything here is multiplied by y. Let's see, it looks like it equals negative 2 ln of x over x squared plus 2 over x squared. So I guess I could just put those together. And all that is times by y, which is x 2 over x. If you plug back in, this is y. So I guess I would probably just say x 2 over x, and then multiply that by 2 minus 2 ln of x over x squared. And I would probably just leave it at that. That looks good to me. I'm going to pause this. I'm going to check the answer in the back. What the back of the book seems to be doing is, first they're taking this, and they're making that 2, and then 1 minus ln of x. Then they're taking these two things right here, and they're subtracting the exponents, because this is the top of the fraction, this is the bottom of the fraction. So they're basically saying that is multiplied by x, and then they're subtracting this exponent from this exponent. And that's pretty much what the back of the book is trying to do there. So these are equal. This green circle is totally fine. Alright, so let's do 127. I have not just made up my mind about 65 yet on page 167, but let's do 127 now. We're going to use the product rule here. We have the first and we have the second. So it's product rule with the new log rules, basically. So h prime of theta is going to equal, that's an interesting theta. That's okay though. We've got this, which is going to be 2 to the negative theta, the derivative of the first, times ln of 2, because that's the rule for that, and in any order, whatever you want, times negative 1, because this derivative up here is negative 1. So chain rule and the extra rule of multiplying by ln of the base. That's derivative of the first. That's all going to be multiplied by the second, so that's all going to be multiplied by cosine of pi theta, plus derivative of the second. Derivative of the second is negative sine of that, pi theta, times the derivative of this, which is pi, and we have to multiply that by the first. So, yeah, that's right. So times the first, which is times 2 to the negative theta. So let's see what we can do for simplifying. We'll simplify in green now. So we've got, it looks like negative 2 to the negative theta ln of 2. this is still times by the cosine, so times cosine of pi theta minus, I guess, 2 to the negative theta sine, or I guess pi sine of pi theta. So it's an ugly looking answer, but nothing really seems to be wrong about it as of right now. If I was the back of the book, I can only imagine that they are going to take out this negative 2 to the negative theta, and they're going to make it now ln of 2 cosine of pi theta. I'm skipping my parentheses here. And then second term minus pi sine of pi theta. Okay, and that was correct, so this ended up being the answer from the back of the book. They just factored this out, which seems like logical. So it's still torn on the I think it is 65. So let me see what I can do about that. Okay, so as far as 65 is concerned, I started to try to do that by hand. It was not really working out. So I mean, you have the graphing calculator, you got to use it on this. I don't have a graphing calculator tool with me, so what I'm just basically going to show you is what you're trying to do is, I guess what you want to do, graph both of them, right? So hopefully you graph them both. You might need them in y equals form to do that, most likely. And then what you want to do is find the intersection. Okay, so that's an intersection point. So there should be an intersection point for both of them. And then what you want to do is you want to find the derivative of, let's say, let's call this 1 and let's call this 2. What you want to do is derivative of 1 at that point, and then you want to do the same thing here. You want to do the derivative of 2 at that point. So I'm imagining when you do this part right here, steps 3 and 4, it might be easiest to do that by hand here implicitly, and then plug in that point and see if you have perpendicular graphs. But I would definitely graph them in implicit, explicit form, y equals form. So this is also going to be probably by hand. And then your graphing calculator will find the intersection. This is where you definitely want the graphing calculator to help you out. So hopefully you somewhat follow this process and you get to an answer. We can talk about it more when I get back if needed. Okay, have a great day, work hard, and I will see you soon.